Welcome everyone. So today, in this videos, I'll be sharing you the course for artificial intelligence. So from the beginning itself, I'd like to tell that I have taken help from many videos and books, and finally made a comprehensive PPT or presentation on artificial intelligence, so that everyone gets a gist of what is actually AI. Let me tell you from the beginning itself, AI is not a technical subject, okay? It is a philosophy, it is an idea, and like it tries to solve the general problems, and it doesn't stick to a single solution. So, based on your philosophy, based on the philosophy of the person who performs the AI, a particular problem can have many solutions. And in this course is going to be a breadth course. That is, we are going to touch many aspects of AI. We are not going to go deep into the course, but we'll be touching many concepts in general. And AI has many subfields. Okay, so suppose even if you're not going to go deep into AI, if you're even if you are going to go to some other computer science field, but you can always use artificial intelligence in some way. And if you want to go deep into AI, into the subfields like machine learning, then deep learning, then this knowledge about AI is going to be very helpful. Okay, in artificial intelligence, every problem can be viewed into four parts. The theory part will be there, the modeling will be there, then algorithm will be there, and an application will be there. Now, let us consider a small example. Suppose we are in like 1990s or 2000, when and we want to create a Google map. Suppose we want to know the route from one place A to place B. Now, how we are going to solve that problem using artificial intelligence? So first of all, we don't know anything about the route and all. We don't know anything. So the first task is to create a computational model of our problem. So we want to go from route A to route B. We have no idea about while going from route point A to point B, there are some potholes in the way, or there is some other issues like problems, or we don't know anything. So we are going to create an abstract idea. We just want to bring that problem to a computational model. So what we can do? So if you see it closely, it's just a way of finding a route from point A to point B. So we can bring this problem to a problem in of graph, where we want to go from node A to node B. So now I can say that, so what is my problem? So my problem is to find the best route from location A to location B, like create a Google map for it. So now I can convert it into a computational problem by creating a graph. So for creating a graph, a graph has obviously the nodes and edges. So what can be the nodes? The intersections of the roads can be considered as the nodes of the graph. And what will be the edges? The edges will be the road segment. Okay. Now, based on our problem, like we can put some weight on the edges also. That is up to us, like how we are going to proceed the problem. Now, what can be the weights? The weights can be the length of the road, or it can be the time taken to go from one point to another. So these are the weights that we can consider. It depends, again, it depends on the person who is trying to constitute the computational modeling. So from this point, we can say what we can say, that we had the problem, and now we had converted that problem into an abstract idea of a we have converted it to a computational model. So this is known as modeling. So whenever there is a problem, it is very important to do the modeling of the problem. Then only we will go on like adding other steps. So we had the problem, then now we have constituted the computational model. Every real life problem, the creating the model is the most tricky part. So once you have done the computational modeling, because whenever there is a real life problem, the model won't be there as it is. You need to think and create the model. So once we have the model, that is a graph that we have for this problem, now what we need to do? We just need to find the shortest path from one point to another. So when the model is there, we will see that already there are many theoretical or theory or algorithms available that can be applied to our problems. So since we need to find out the shortest path, we already have many shortest path algorithms like Bellman-Ford, Dijkstra's, and many more. So based on our like what will fit best into our problem, we can choose an algorithm and apply to it. So that will be the algorithm part is there. Now theory obviously will have to go through all the theory to understand what type of algorithm will fit to your problem. So once you find out your algorithm, because in most of the cases after creating the model, the algorithms already exist, and in few scenarios you can create your own algorithms also. Now theory, so now we have the modeling part over, theory part over, algorithm is ready. So now you just need to apply it to your problem, and you need to find out the best solution. So this is how a problem can be solved using all these four topics. So is it clear now? So what will come into the application part? So after applying the algorithm, suppose I want to go from, suppose I'm giving one example. I want to go from Guwahati Club to say, or suppose I want to go from Guwahati Club to Azara. Okay. So if I want to go from this place to that place, do I need the map of the whole world? Do I need the map of whole India? No, right? I just need the map of maybe Guwahati city. So that's how I need to apply it. Like what based on my problem, I need to apply all these small things in my application part. Now what will be the theory part? Now the theory part will be what can I proof from my problem. So after application is over, what proof can I get from my problem? Like can I prove that like Bellman-Ford is the algorithm is the best algorithm that finds the shortest path, or is there some other algorithm that finds the shortest, some sort of proof? So that will constitute the theory part of the problem. So here I have just written down theory, modeling, algorithm, and application randomly. So based on the problem, the ordering can come about. Okay. Obviously, problem is there. First will be modeling, then algorithm, then application, then theory. But in some cases, it can be the order may be different also.